And I'm back. I didn't have coffee just because it's almost 7 p.m. so probably would keep me up at this time. Although I should try, maybe. It would be fun. Anyways, so let's look at this one right here. Sine of x squared, and then you have an x here. Seems like the derivative of this x squared is going to give us something that will be related to this x. So let's try that. So let's write u is equal to x squared. And then du would be 2x dx. And then, let's get the colors. We have the x dx part right here, and then we have the x squared right here. So it seems like we have a sine of u, and we want to get rid of this 2. So we multiply times 1/2, and we get x dx, and now I have exactly what I wanted in yellow, and the sign of course just stays like that, and this becomes 1/2 of du for the yellow, and for the green it'll be sine of u. And then let me write the antiderivative, and here we're going to have negative cosine of u plus c, and let me write it, let's continue in a line which looks ugly, but oh well. Cosine, instead of u we write x squared plus c, and that is your answer. Now let me say a word here. A lot of you would have said, well, why didn't I grab sine? Okay, so why not sine? So sine of x squared. That's a very common question I always get. Well, that would be because if you do that substitution, you would have du, derivative of the sine would be cosine of x squared times the derivative of the inside, 2x, and then dx. So I don't see any cosines here, so that would cause a little bit of trouble. So that's why you would not want to do cosine. So that's the answer. So what about this one? Well, the square root of tangent cannot go well. That doesn't seem like a good idea. So let's choose u equals tangent as our u substitution. And what happens is derivative of the tangent, you get secant squared and then dx. And you see how in this case it's straight up what we needed. I get secant squared dx right there, and then I get the square root of u du. Square root of tangent, square root of u, and secant squared dx du. And this one you treat it as a u to the 1/2, so it becomes u to the 1/2 plus 1, which is going to be 3/2, divided by 3/2, or you can just multiply it times its reciprocal, which is 2/3 plus c, and then you take back your substitution and you get 2 times tangent to the 3/2. It looks ugly if you put it here. Oh well. Nothing that has ever stopped me. Plus c. Alright, so that is that. Now, for this one, well, let's look at the ugly part. Everything looks pretty ugly, so let me start by factoring a 2 out. Then things may look, oops, I didn't mean to write a parenthesis, I meant to write an integral sign. Let's see what we have here. Then I have that dx, and then I have e to the x plus e to negative x. Okay, so let's take a look at this expression. Oops, I forgot a square. Look at this expression right here. Derivative of e to the x, e to the x. Derivative of e to negative x, negative e to negative x, which is just what I have right here. So this substitution works great. So let's do u equals e to the x plus e to negative x. And then your du becomes e to the x plus e to the negative x times negative 1 or minus e negative x dx. And in this particular case now, we have the du pops out perfectly right there, and then the u in the bottom becomes a u squared. So I get 2 times the integral of that yellow stuff becomes du, and this in the bottom becomes just u squared. By the way, I should probably also use colors so you see the end result. As the yellow becomes a du, and the pink or whatever that color is becomes a u. So then this is u to negative 2, and then you just copy the 2, u to negative 1 over negative 1, then plus c. And that becomes negative 2 over u, which is e to the x plus e negative x. Took back the substitution. I just took this u to negative 1, put it as 1 over u, and the negative comes out here. And then plus c. Always remember that plus c. All right. Now here, you could do a u substitution of sorts, but this is a trick one, so you can actually see that you don't always have to do u substitution. If you distribute this e to the x term by term, e to the 2x, you could write it as e to the x squared over e to the x. Then plus 2e to the x over e to the x. And then plus 1 over e to the x, or you could write it as e to negative x. All that dx. And then you can see that e to the x cancels the square, e to the x cancels e to the x, and you're left with the integral of e to the x plus 2 plus e to negative x dx. And then you just apply your, well, technically I do have to do a substitution for this one, right? I have to do u equals negative x. But that one, I don't think we have to do that. So e to the x for this one, because the integral of e to the x is e to the x, the indefinite integral. Then 2x for that one. And here, I said I didn't need it, and I put a plus. Minus, that's what I need because I have a negative right here. So minus e to negative x plus c. Why did I put the minus? Well, that would come if you write u equals negative x, du would become negative 1, and then it would change this plus to minus. You can check that if you take the derivative of this expression using chain rule, you get plus e to negative x. All right. Do I have time for one more? I think I do. But it is a definite integral, so I'll do that one in a third video. So I'm going to make 3 videos. Alright, so let's leave this one at that, and I will put the link for the third video in the description below. Alright, that's that for this one then.